And now to finish off the videos for integration by substitution, we'll look at another application, and not surprising, this application is one where you're asked to find the area. So, as you know, to find the area enclosed by a curve, we have to have an understanding of the sketch of the curve. In this particular question, we're asked to use the substitution u is equal to x squared minus 1. So it's back to the, I suppose, type 1 question. But in terms of the answering the area aspect of it, you know that you have to be able to sketch the function. So recall your curve sketching techniques. And unfortunately, this time around, we didn't do this topic after polynomials like we normally or have previously done. So we haven't done polynomials yet, but you'll see that when we do polynomials, it helps us just to identify where the graph cuts, where the graph of this function, where it cuts the x-axis. But we already have a bit of an understanding of that. We know that where the graph will cut, the x-axis when y is 0. So how do we get a 0 in this spot? How do you get 0 equal to 3x times x squared minus 1? And notice this is nicely set up as a multiplication equaling 0. So that's really nice that it's been factorised for you. I suppose it hasn't been fully factorised. To factorise x squared minus 1, you know that that is the difference of two perfect squares. So now we can see the only times that that will ever be equal to 0 is if x is equal to 0. So we know that the graph's going to cut there, or at minus 1, or at plus 1. So down here at minus 1 and up here at plus 1 will also cut. What we also know is that's a cubic, because if I expanded that bracket, my highest power would be 3x cubed. We know that cubics either look like that, or they look like that, or without any complication, they just are strung out like that. So we know it's this one because it's going to be positive. 3x cubed, the x cubed, the highest term is a positive, so it's of that outline. So we know that our graph's going to do that. Now, and you can do all of that without having done the polynomials chapter. What have we got to do? We've got to find the x-axis, the lines x equals 0, which is between here, and x is equal to 1. So we actually know that we should, if we take the integral, which we will, so the area would be the integral from 0 to 1 in terms of x values of 3x x squared minus 1 dx. We should get a negative number, so let's take the absolute value. We've been instructed to do it by substitution. I'm not so sure I would if I had the option. I think I would just multiply the bracket out and simply stay in terms of x. It's not too difficult. That is not difficult to integrate, although it's a product there. We could expand the bracket. We've been told to use u is equal to x squared minus 1. This is a time when I'd actually say that to do it by substitution is making it more difficult. And if you read back here, it says this is not a typical HSC style question, but gives us some good revision anyway. Okay, so let's see. I've chosen to take the 3 out and take the integral 0 to 1 of just x times x squared minus 1 dx. You might be wondering where that came from, and it came from, well, I guess over here I used their instruction that u had to be x squared minus 1. So du dx is 2x. Now that gives me that du is 2x dx. I would have liked 2x, but I didn't get 2x. So At that stage, I thought it's probably easier just to go to an expression in x dx by dividing both sides by 2 and create an x dx inside the bracket. So that's why I've taken the 3 out, leaving the x dx, and I will have du on 2, which I will adjust. So the other thing that I need to do is to get my limits of integration correct. When x is equal to 1, as it indicates here, then u will be 1 squared minus 1, which is 0. And when x is 0, 0 squared is 1, is 0, minus 1 is minus 1. So my new integration becomes 3 times the integral, we're going from minus 1 to 0, of x dx. I'll put separately, this u squared minus 1 can be replaced with x squared minus 1 can be replaced with a u. X dx is du on 2, which means I'm also going to take out a half. So I'll have 3 on 2 out the front now. The integral minus 1 to 0 of u du. So doing that integration, add 1 to the index, divide by the new index, we're going from our u values, minus 1 to 0, subbing those in 0, gives us 0, subtract, putting minus 1 squared plus 1, so it's a half. We're expecting a negative inside there. We could see that from the graph. The absolute value of negative 3/4 is 3/4. And it's area, so it's units squared. And you should be right to do the rest of exercise 6D.